Hello and welcome to another episode. You might be wondering why am I doing it on this? And my answer is because I don't have a pen or paper. So we see all these quote unquote. Yeah, this is supposed to be roads. And let's say all the destinations are like here. And let's say all of them are equal, even though they're obviously not. Let's say all of them are equal. Yeah, makes sense. Now, what would you say? All of them are the shortest road, or none of them are the shortest road? Well, I personally think that the none is actually more correct because they're all equal. So then, if you really think about it, in absolutely every case, all is a synonym of none. I mean by, yeah, you just gave a really dumb example. And let me think of another example. Oops, shit. Okay, I just came up with another example. Let's ignore every odd number. So we have only 2, 4, 6, 8. Yeah, so what is it? All of n are this is divided by 2, and n is number, it's pretty obvious, or none of n it technically is divided by 2 because numbers are non-countable. I know that makes no sense if you, yeah, all of numbers, yeah, it's a. Now you might be like, well, absolutely, of course, all the numbers are divided by 2. Oh yeah. But then, let's get to that later. I haven't come up with a clever explanation for that. I just came up with a clever explanation as to why they're not even. Okay, so they're all even or divided by 2, right? Well, in a world where every single number was divisible by 2, we would never bother separating them into not divisible by 2 and divisible by 2. We would only have one of the sides, and so we wouldn't know about the other side. Never. We would just know about this side. And so we would never come up with the special term even. And so then actually none of the numbers are even because they no longer have their property. Because all the numbers have their property. And now you might say, well, all the numbers, whatever they are, like real, I don't know what all the numbers are. There's some complicated name. And let's call that complicated name, what should we call it? Yeah, all n is whatever, let's say, let's say A. I don't know how to draw alpha, just imagine this alpha. Yeah, so absolutely all the numbers are A. And now you say, well, yeah, there's no way you can turn it, yeah. Let's come back for a second, because I realized there's a bit of plot hole. You still may not be convinced about that divided by 2 thing. You may be thinking, well, yeah, they technically wouldn't be even, but they would still be even. They would still be divisible by 2. Yeah, but that's not the point. Yeah, that's technically still true. But really, no one would call it even. They would just call it A, because they're part of all the numbers. You might be like, okay, but what if some guy somehow invented an imaginary number, which is a part of A, because we're talking about all numbers, that is non-divisible by 2. Some dumbass guy, in their worlds, where everything is divided by 2. Well, in our world, we cannot take the square root of negative numbers, because, it never equals anything negative, because it's 2 times. And minus minus equals plus. Yeah, because it has to be the same number, and plus, I forgot it, this is on paper, and plus equals plus. So in both the cases, if the number is positive or negative, this number has to be positive. So we cannot take the square root of a negative number. But some dumbass guy came up with the square root of negative 1 is equal to I. This looks like J, whatever. And yeah, do we have a special word for I? Yeah, it's an imaginary number. So what would they call that number that is divisible by, that is not divisible by 2? They would call it an imaginary number. Pretty obvious stuff. At the stall, you're like, yeah, I'm on board. But you still might be like, well, then wouldn't they call the non-divisible, the normal, even numbers? Stop calling them normal numbers anymore. And in our world, have we stopped calling normal square roots something else than square roots? No. Because it's obvious that this has to be a positive number. We don't call them negative square roots or positive square roots, because we know we are, yeah. And so, yeah. And yeah, now back to this always ends A. And yeah, I might have convinced you at this point, basically. I forgot what I was going to do with this A. I maybe already did it and I just forgot. And now we're going to do the second part of if all the numbers were even. Now, I still haven't come up with a clever solution for this, so it will be interesting to brute force together. So, O n is divisible by 2, or OA, at this point, because, we defined A as all numbers. So yeah, let's do that. Let's use our terminology. A is divisible by 2, which means all numbers is divisible by 2. Okay, so how can we transform this into norm of all the numbers, which is A is divisible by 2? Well, we already talked about how it is on a psychological level, but now we have to talk about it in a bit more of a physical sense, because they're obviously all divided by 2. We cannot argue that. If all the numbers are even, that's their definition, they're divided by 2. Now let's start thinking about why it's none. Okay, so let's compare this with the roads. I don't know, it might help. So this road is 2, this road is 4, and this road is 6. Now, let's say that's all the numbers. Why not? And this. Okay. This is the endpoint because so they all can be equal. So all the roads. Okay. I came up with something. Okay. Let's show all the roads again because they actually came up with something, with some BS. Can you believe it? Okay, so this is 2, this is 4, and this is 6. So, let's say this means all the roads, right? It's that divided by 2 shortest. Or in other words, are all the roads that are divisible by 2 the shortest? Now you obviously see that all of them are divisible by 2. So technically yes, but we all know that all equals none, or we're at least trying to prove that in this video. And so we could obviously say that none of these are the shortest, because it's pretty fucking obvious. None of the roads that are that are divisible by 2. And so then we can ask, that aren't divisible by 2. We'll say S is the shortest one. And so you might obviously be like, what? There is no road. There's only 2, 4, 6. And yeah, let's I don't know I know where I'm going with this, but I don't know how to format it, because the answer to this is yes. I don't know how to format it though. Okay, so if none of this are actually the shortest, something has to be, in a larger universe. We already said this is all the numbers, but still some other road that doesn't have a number, that has a number, that one imaginary number that one guy invented, remember him? Is that road the shortest? Well, let's get into Now for that road, it could either be less, more, or equal, or it could be anything. We don't know anything about it. It could be shorter, longer, or equal. That's one's obvious. I won't explain it. Okay, so why are we so certain that it is yes? Now that I actually start thinking about it, we are not so certain, but we're still pretty certain. We're not 100%, we are like 90%. Okay, so all the even roads, or all the roads, because they're technically not all the roads. Now that we know about that, hidden or here, I road. And so Oh, the light is awful. Okay. So, wait, this looks like a 5. So, if all roads divisible by 2 are not the shortest, because they're all equal, then this road over here we don't know anything about it. Why did I say we assumed that it's yes? Or whatever. Still. So let's write it out, so we can make an allegory. So all roads divisible by 2 are equal. Therefore, none of them is shortest. Yeah, I have pretty dumb symbols, and this doesn't look even like division sign here. Okay, so let's replace this with numbers. Now, all numbers divisible by 2 are not equal, that's obvious, but they're in the same category. Now you might say, well, you just explained why it wouldn't be a category like 13 hours ago. And I say yes, but they're still in the same category, dude. In their world, it's not in the same category. It's in our world it is. We don't live in their dumb ass world where all numbers are divisible by 2. Okay, so A2 are in the same category. Therefore, none of them. Oh, here it's R again. It's very complicated. What can we replace less with? Now, it has to be some very technical term. So, if all the numbers divisible by roads divisible by 2 are equal or in the same category, we learn how to allegorize the first row. Now I have to do the second row. So none of them are outside the category. Yeah, so none of them are the opposite of this, or minus this. That's obvious. So I'm still trying to make it up. We're pretty close, as you see. So what do we replace this sign with? That's our problem now. Now, let's see. The roads. We want to add another road just for funsies. Are all equal. All roads divisible by 2. This looks like a chemical compound, for fuck's sake. Oh my god. Okay, so yeah, all roads divisible by 2 are equal, so none of them are the shortest or longest, whatever you want. So shortest has to allegorize or semi-equal, not divisible by 2. Now, we have to look with the roads, which is obviously a kind of simpler example. But once we do it here, we should do it in the real world, or in the bigger example. Okay, so What did I write? I haven't honestly forgot. Yeah, shortest, not shortest, equals not divisible by 2. Yeah, we have to do that. Okay, we have to do that. So this, technically, we know it's true. We don't know it's true. We are trying to prove it's true. So we have to put a question mark on this equal so we can't use it as fact. I was going to. Okay. So, let's say we have to replace them immediately. And so, then immediately, all of these are non-divisible by 2 if these are equal. That's why I put this question mark here, because I was planning to do that. Okay, I think I came up with some BS. Okay, yeah, I think I did come up with some BS. So, all roads divisible by 2 are shortest. Not shortest. Well, never, both are true technically. Now, why don't we replace shortest with non-divisible by 2? Now, that means that non-divisible by 2 has to equal not shortest, which we know this is true for all the roads. So if this equation sign is true, then it is true, because we know this is true and we know this is true, which there is a hidden equal sign here. So now we have to prove this equal sign, which is kinda fucking hard. So we have to prove that shortest is equal to non-divisible by 2. Not shortest, technically. Both are true, technically. That's what I'm trying to prove, that O equals none. Remember that when that was the topic. Okay, so I'm really trying to come up with some clever way of simplifying it, but I can't. I'm trying. You're getting ever so close. I think we'll be able to do it in within 30 minutes, not hours, dude. And so come on. So if every number, or if every road is not divisible by 2, then that would defy logic. Oh my god, dude, I'm contradicting myself. Okay. Try to think about it, Michelle. There has to be something here, hidden. Okay, dude. Okay, I came up with some sort of progression while I was off camera. So, if all numbers are not divisible by 2, why are they not divisible by 2? We have to ask that question. Not the question, how do we make them not divisible by 2? We have to ask, why wouldn't they be divisible by 2? And now I'm going off camera again to think about that one. I think I came up with some BS of an allegory. Okay. So, let's, oh my god, I'm so excited. Oh my freaking god. We're getting closer. I came up with some sort of simplified version of this, which is good. So, we have 3, 6, and 9, all here divided by 12. Yeah, I don't bother, but these are all different mathematical problems. Just I didn't bother separating them. So, which of these is the best divided by 3? None of them. They're all equally good divided by 3. They have nothing left over. They're all a multiple of 3. One is even a power of 3. So yeah. This is 2, by the way, if you dot dump. It's 9. So yeah, none of them are best divided by 12. So here we have x equal z divided by 2. Which of them is best divided by 2? We have no idea. Let's say we know all of them are divisible by 2 because this is in our real world now, not in this where dirty 3 exists. So which of these would best be divisible by 2? Well, all of them or none of them. All of them are true. You still remember when we tried to prove this bitch. Okay, so don't get angry. I think we'll prove it until we hit the 30-minute mark. So should I go off camera? Maybe. Where does this fuck does this lead to? Oh, let's think about it. I'll leave it on camera this time. Okay, so what can we get out of this bitch? Okay, so we can replace best with all. Like all numbers are not divisible by 2 because none of them are actually best divisible by 2. Maybe. Let's try that BS. Okay, so you already heard me, but I still cannot have to explain it. If none of all numbers best divisible by 2, then yeah, that's it. Oh shit, that fuck is loud. I'll continue when this BS ends. Okay, I came up with some BS while I was waiting for the vacuum cleaner to end. So in a real world, if nothing can be best, so 1, 1, 1. Let's say the winning spot is being divisible by 2. Pretty dumb. Well, this was amazing. This solved it. This right here, but I forgot where I was going with it. I'm so angry with myself. Yes. Okay. So you see the allegory. The winner gets to be divisible by 2, but they're all winners. So when they're all winners, there really isn't any winner. You might be like, well, it's about the competition, not about the winning of the competition. I know you're dumb. We're not talking about that now. And of course it's about winning the competition. But that's another point. I'll talk about that in the next PP break. This technically is a bit of a footnote. So if all of them are winners, then none of them are really winners. So if all numbers without even trying get to the winning spot of getting to here, then really none of those numbers are actually winners, and they don't deserve to be called divisible by 2. Yeah, I'll wait until 30 minutes, so I fulfill my promise of revealing this at the 30-minute mark. Pretty dumb, if you ask me. Hopefully Kamen will watch all the way through. Kamen, if you watch all the way through, comment banana. Bye.